So everybody knows Qualcomm has been an edge company for a very long time. And not to tout about our company, but we've been really good with communication and wireless connectivity, with increasing footprint on on-device AI and on the edge. We have increased our investments in this space, and we are essentially um, well positioned to basically cater all the way from smart home and networking to robotics to manufacturing to enterprise use cases and many more. And at the heart of all of this, we strongly believe that developers are key to our success. Now, all of this might seem to this audience as something like easy peasy, you do this every day, but in a Qualcomm machine, a developer first experience is something very, very new. The whole idea that we have to make sure that we prioritize developers. We are focused on open source software, participating in open source communities, both using and giving back to the communities is a new muscle we've grown over the last few years, especially in IoT, where we think this is 100% required. We've been trying to make sure we adhere to standards, to APIs, to processes, and such a way that our people are easily can swap between our competitors' hardware to ours. And to do so, we have been working to provide SDKs and tools, working to provide documentation, community forums, and an Ubuntu experience that people are used to. Uh, Recently, we increased our commitment to our developer community. We acquired Arduino. So Arduino has joined the Qualcomm family. This basically highlights our commitment for open source hardware with open source software. As part of this acquisition, we announced the Arduino Uno Q platform, which is based on Qualcomm Dragonwing QRB2210 processor. It runs with completely open source software with Debian Trixie. And this is the very first time, literally the very first time Qualcomm runs with complete open source software on our hardware. And we are already working with Canonical on our next gen Arduino platform, which will come preloaded with Ubuntu. So how did our journey start? We started in early 2024, and this year has been all about all the hard work we put last year for reaching the milestones and making releases. We now have on several platforms, both desktop and server versions supported and certified. These are some of the very few platforms we have been working on. So we have Ubuntu optimized images for QCS5, QCS6, and our IQ9 boxes. And if you're using one of those Snapdragon X Elite laptops, ARM laptops, they run out of the box Ubuntu image. Thank you to the Ubuntu community for all the assistance there. So please do, our roadmap is growing and we're adding more and more platforms in ready to use for any developer. So beyond providing open source hardware, open source software with Ubuntu, we also provide an end-to-end ML ops tool with Edge Impulse that allows you to take your own data, whether it is sensor, vision, audio, train it with a gamut of models that are available as a SaaS platform and go deploy it on the field. So this helps us complete our whole AI story from starting with hardware to software to deploying an AI ML apps. So how exactly did we get here? The journey was not simple. We are an embedded company, so we started with embedded systems, and now here we are with an experience with Ubuntu. So I have Adam, who was one of our principal engineers, and Ameya, who will join us later to talk about how they made it all possible.
Okay, so we'll start with what our overall Qualcomm Linux software stack looks like. It's not important too much on the details here. The key thing is coming historically from custom Yocto distribution means of giving our software, most of what we had in place was focused on the image. It was focused on a full rootfs, same as open embedded build system using BitBake with layered recipes. We have these curated in MetaQCOM to comprise our BSP and our SDKs. Of course, with Yocto, you're generating this full image as your output, and we needed to start to look towards supporting Ubuntu, and we worked with our Canonical partners, but I just wanted to share some of the challenges, learnings, and things that even might seem trivial to many of you with the deep expertise, but it's just a way of thinking and a way of organizing your systems and infrastructure to be able to support the Ubuntu way. Having all of your software as discrete packages, enabling independent builds and updates and the basics. And so these are some of the, oh, looks like I got a little misaligned here. But first, it does take shifting the paradigm of how we saw our software and how we organized releasing that software. So from platform team, I was helping enable all of our software teams to work towards being able to think in terms of their deliverables as independent packages. So first, that just means enabling independent build. You can't rely on the recipe, all of the Yocto magic that is pulling in dependencies that you may or may not know completely or have not fully specified. Versioning is critical. Versioning becomes much more critical when you're working in independent packages. And so we had to build into our systems, taking into account, work with our teams to properly version their shared libraries, have the concept of package versioning, and work in CI checks to ensure that this is upheld across those ABI and API boundaries. It's critical to manage your dependencies, understand your dependencies. So we had to break out from this nested recipes, true understanding of what your software depends on, and this gives a lot of insight into how you're intersecting with both the upstream projects that you're dependent on and the other modules within Qualcomm. And the final product does need to be a single build, but instead of focusing on the single image build as your custom output of your system, it needs to be assembled from the set of packages that all support all of our SoCs. And so this was a challenge, but it was a big success, I think, of all of our teams shaping how we deliver software to enable one common image and be able to install this functionality through packages. So after this, what we're working on now is open development. Start bringing these efforts onto GitHub, looking at implementing our packaging repositories, GitHub Actions and workflows to do the package building, and start to work directly with the community and open up the processes that are now that are now shifted into supporting this new paradigm. Key part of that is focusing on upstream first development. It goes for both kernel and our user space stacks, and hoping the effort will excite people to be able to work on our platforms, and maybe others who are looking at developing from a more embedded traditional framework of say the Yocto builds. I think working with our canonical partners has been very beneficial, also in feeding back to our shared code base with Yocto, because these are all basic. The key items I went over are not, of course, novel here. It's just critical importance when you're dealing with the modular packages, and there isn't a large full build system to fall back on. So I'll hand off to Ameya now to go over some of the details of our stack.
So, hello everyone. So thanks Pragya, thanks Adam. First, a big thanks to Cindy and her team, Qualcomm engineering teams who may be online, and the Canonical engineering teams as well. So what I'll touch upon is some of the details that Adam covered, but a little bit of a layout of what we have on Yocto, which is on the left side. I don't have a mouse, or no. Okay, what we have on the left side, which is essentially our technology stack, and how we have kind of managed to Debianize it in a way to move it to Ubuntu. So in a sense, as many of you know here, right, we will have certain Qualcomm or certain vendor-specific firmware artifacts which will remain proprietary. Those are boot and boot critical firmwares, the security firmware. There is an hypervisor EL2 layer that we have, which we run Gunya. That is something that we do it for our Yocto offerings as well as Ubuntu. And then essentially from the green and the blue boxes, right, are essentially all the OS level stuff, the HLOS or high level operating systems fit. So the common block between Yocto and Ubuntu is the red blocks. And of course the Linux managed firmwares, which are the DSP firmwares, video firmwares, GPU firmwares, those are all anyway contained as a part of rootfs. Now, what we have done is we have taken essentially the same QC firmware artifacts. On Qualcomm Linux, what Adam was pointing out too, we have 6.6 kernel. And then essentially since Yocto, it's custom, we build our own system image. But now with 2410, we had to realign our kernel base port and our SOC infra drivers to 6.8. And then also essentially the upstream technology, the technology stacks that we have, many of them have upstream components. I'll talk about base and custom quickly, but what we meant is all of this Debianization we had to do so that it gets accommodated or it gets assembled in the rootfs. Now, again, the key part here that I want to highlight and quickly touch upon is there are some technology stacks which are very SOC specific. So for example, like Pragya was showing, right? We have 4 reference platforms. Not all, like if I have to pick up, say, camera, for example, right? The camera kernel driver and the camera user space drivers, those are very SOC specific. That means we have a separate KO for one RB3 Gen 2 platform and one KO for RB8 platform. So we have to kind of come up with a way that it should accommodate or it should fit in that single system image concept. And many of you guys know this, so I won't cover it, but we worked with Canonical team. We had to come up with more like UDEV rules around it to make sure that the right KO is loaded based on some of the device attributes that we expose in our kernel drivers to make sure that, like say for RB3 Gen 2, RB3 Gen 2 KO is loaded, RB3 Gen 2 user space packages are loaded, rightfully it will happen for the future platforms as well, until we kind of have binary compatibility for all our kernel and user space drivers. Firmwares anyway will be different between different different SoCs. Now, this is a little busy slide, so I'll talk later, but I want to kind of quickly again go over one workflow that you will see in the demo room with a Jim Pulse. Jim is here, so he will also articulate a little bit more on the demo. But what here we want to highlight is we have our hardware blocks, the CPU, GPU, NPU, and the camera. NPUs are essentially the DSPs. And if you want to have a workflow, what are the packages that you need to kind of touch upon to make sure that you can realize an end-to-end use case? Say, for example, we have these three packages, CamX, G, and CamX libs. These are the packages that are there today in Qualcomm PPA. A developer can actually install them using the standard apt get package, the package mechanism, and then also these SDKs, which actually are an abstractions to these higher level plugins, the IM SDK plugins, which are again GStreamer based. So with a GStreamer front end hooked on to our camera and the graphics technology stack via the QNN SDK, we can actually delegate, or we can decide, a developer can decide what is the end payload they want to execute there, what they want to render it, which hardware they want to render it, whether it's on the GPU or on the NPU. So via configuration and these SDKs, you can actually create an end-to-end developer workflow. Now this picture which is shown here is the device we were trying to set up here. And what it shows is this is RB8. This is IQ9075 platform. Once you flash this with the boot firmwares, the Ubuntu root affairs, the Ubuntu device tree, once you do that, it becomes your workstation. That's in a way a developer's life, if I have to put it. You can actually use, it becomes a true SBC, which is going back to this slide. It's very verbose, so I won't go through it. But in essence, if you're patient enough, you can build the entire kernel on the device. So I have it built on my RB8. I can create multiple kernels. I can decide which kernel I want to load, depending on my grub configuration. And that allows developers to kind of tinker, to play, to kind of test the hardware and perhaps even break it. So this is one way where you can kind of really good for embedded developers coming from the Yocto background. There are other things, which is touchpoint 2, where Qualcomm PPA, which is what Adam was referring to, was that these all packages that was relayed out in that table, many of them can be downloaded. You can do on-device compilation on them. You can change the touch point, and then you can customize it. So in a sense, you have a way for a developer who buys the platform to take the source of the packages, to what extent they are allowed to. Like some of them are proprietary, but and essentially develop their own use cases around it. Of course, and with the apt Debian repository that we have through Ubuntu, right? It really makes life much easier for developers who are more accustomed to like a community Ubuntu environment. Whereas in the case of Yocto, where I come from, where we were dealing with very customer specific, it's a custom image, so it's very customer specific. So, but with Ubuntu, I think you will get a chance to experience the Qualcomm SoC and kind of work on these touch points that we have relayed out here. So with that, I think I can give it to Cindy, who can talk further. Yeah, thank you.
Yeah, so thank you to the Qualcomm team. I'm Cindy Goldberg. I'm here from Canonical. I'm actually speaking on behalf of our partners from Thundercom, Roger, Ali. We're thinking of you. I'll do my best to tell everybody about the amazing product that has now been launched thanks to the fruits of this work between Qualcomm and Canonical. and that is Rubik Pi 3. It's really nice, right? So let me tell you about it a little bit, and you'll be able to see more and play with them in the unconference room in just a little bit. So first of all, on the hardware side, we're starting with the 6490 chip that you heard about from Pragya, Adam, and Ameya. And so we start with this very high performance AI capability, as you saw, in a pretty small form factor, very much targeted to developers, so 12 TOPS, and high memory. So you have all this great hardware, looks like you're all probably very excited to go play with it. And then in terms of the software that we have on top, as we said, we have kind of an out-of-the-box, preloaded with Ubuntu. It just works, all of the features. We have Edge Impulse that Pragya spoke about, a recent acquisition from Qualcomm, bringing a lot of that AI software for the Edge applications directly as part of this experience with Rubik Pi, and a number of other applications kind of ready to get developers started. And so with this, Rubik Pi, this is where I do my game show host imitation. Anybody want to guess the retail price of this? There may be a prize waiting for you.
99.
Oh, Heinrich, you cheated. You looked at our other partner Arrow's website and saw that these Rubik Pis from Thundercom are indeed $99 as of today. So stop by our room. Thank you so much for all the teams who've worked on this. Thank you, Qualcomm, for giving us this opportunity to partner with Thundercom to bring 6490 directly to developers. This should be so much fun. Very excited to see what happens with it. So thank you.